Thank you for tuning in to today's TLDR episode of the Breaking Changes podcast. I'm your host and chief evangelist for Postman, Kim Lane. With Breaking Changes, we explore specific topics from the world of APIs, but looking at it through the lens of business and engineering leadership. Joining me today, we have Maxime Beugnet, Senior Developer Advocate at MongoDB. Maxime shared his journey with me becoming a developer advocate with MongoDB and what the modern database stack looks like behind the web and mobile applications that we all depend on. Let's start with the basics. Who are you and what do you do?
Hey, so first of all, thanks for having me on this podcast. That's really an honor to be here and to be noticed, and to be on the Postman podcast. So I'm Maxime Beugnet. I'm a developer advocate based in Paris in MongoDB. So I work directly for MongoDB, the database company. And I'm a DevRel, so I build a lot of content for the community. I take care of the community. I try to solve their problems, on the community forum, for example. I publish blog posts. I occasionally participate into podcasts, or I do YouTube content or live content as well on Twitch. And also my main role is doing conferences. So I send also a lot of CFPs to a bunch of conferences. And then, of course, I go there usually in person if I can, or, with COVID, sometimes it's online, and I try to deliver those, afterwards.
So what got you into DevRel?
That's a good question. I actually, it was kind of an accident, right? I guess initially I was a consultant. I was working for Zenica, which is a consulting company based in Paris. So, working for clients, et cetera, the usual consulting job, right? And this company also happens to be a training center. So that's where I actually started to become a trainer and, upgraded my skill, to talk in public, present things, explain, build up some pedagogy skills, et cetera. And I learned about Java, about MongoDB. I became an official trainer, and I got interested as well in the meetup in Paris. And I took the lead actually of the MongoDB meetup in Paris. I felt like that there just wasn't enough, so I became a leader, and then I was running the meetup for a couple of years. And that's how I met my boss, basically, Joe Drumgoole. And he just came to me, was like, well, you do that for free. And the MongoDB meetup in Paris is like one of the most successful one, in the world right now. And you're not even an employee of us, right? You just do that for free. That's amazing, So that's how we started to talk. And he was like, we can pay you for that. I was like, really? And that's how I came in.
I always want to try to share with other folks how we got into the industry, because developer relations is a really growing area, and I always trying to encourage people to join and participate. So I think taking leadership in your local meetup is a good way to do it, because meetups are kind of, before COVID and hopefully again here after COVID are kind of central to how we do what we do and connect and networking and help each other, as well as all the other things you talked about, podcasts and blog posts and other things. So when you do your work, we as developer relations, we tend to focus around a handful of technologies, tools, platforms. What do you focus on when you're doing developer relations? MongoDB, but is there a special part of Mongo or database aspect that you focus on?
So it depends, because the team expanded. So if you asked me the same question 4 years ago, it would be a different answer, because it was just me and my boss basically covering all Europe at the time. Now in Europe, we are like a team of 10 people, and probably like double of that, in the US now, about 30 total, I guess, in the team. So we develop some specific areas, right? So for example, one of my colleagues, Mike Lean, is working on our podcast, for example, he's working exclusively almost on the MongoDB podcast, for example. So for me, I'm more doing conferences. I'm doing content on the blog. I'm doing Twitch Live, for example, which is not everybody doing that in the team. So we develop some, specific areas where we want to focus more, and goes by affinity, right? It's kind of, it's not imposed on anybody, but Michael just like doing podcasts. He's like a sound geek, I would say, in the team. So, he's all about this. So yeah, I would say that's where, naturally he wanted to work more. And for the MongoDB side, what we talk about also depends on what we like. For example, I'm more a backend person. So usually I'm more working around the different languages like Java and Python for my part. Some other people are focusing on C# or Node.js and other languages, for example, that can, connect easily with MongoDB. And recently I was also in the team called the Realm team, which is a MongoDB backend service, the serverless backend service that MongoDB offers on top of MongoDB Atlas. And so I was focusing mostly on that area in MongoDB Realm, but now I just changed team actually, so I'm covering more the whole MongoDB platform actually, so I can really blog or talk or present anything that's related to MongoDB. So
I'm an old database person. I've been doing databases since the 1980s for a long time, and I'm big on relational databases. And then I learned a lot about the NoSQL kind of world. What's the current state of databases and what does it power? I mean, I know web and mobile, but what are the specific features or capabilities that support single page applications, mobile devices? Like, what are the benefits beyond just data storage these days?
Well, the main benefit of MongoDB is the fact that we don't store data like SQL, in tabular, ways. And the schema design is very different. So usually when you move from SQL to MongoDB, you have to rethink the whole schema design, and you have to redesign completely the way you store your data. Usually when you do a single page application, it means that behind that you have one query at least that's going to run, to the database, fetch some data, and then build the page, right? And usually in SQL, it means that it's not one query, but it's actually like a bunch of queries that's going to go do some select, on a few tables, or it's a giant query that's going to rely on, select and then join, because you have to actually travel through multiple tables to fetch all the data you need. But in MongoDB, we try to change the perspective and store all the data that lives together, that needs to be presented together in just one single collection, right? So, we try to store basically objects that make sense for you as a developer or for the user as a person, right? So, for example, if you manipulate like person and contract and these kind of things, you're going to find exactly the same object, mapped from, I'm going to talk in Java for, your POJOs, or, equivalent, it's like kind of the mapping layer on your application. So those object that you manipulate in your code, that's going to be mapped, one-to-one almost in the MongoDB database in the end, right? In SQL, you would have usually to chop down all those tables, or, all those piece of object, you would have to chop them down into tables because, you can store arrays, for example, and you can store like multiple addresses. So you need to do a join table, etc., etc. So all that layer of complexity, usually you can remove that in MongoDB and just store everything together. And basically the data that needs to be accessed together needs to be in one single collection, one single document. That's usually how we try to build that. And because you do that, then it's more efficient query-wise or for the indexes, etc., etc. So it makes the whole thing more performant and more efficient.
So it's really tailored for the application, how I'm trying to deliver this information and use the information in the application rather than just a massive database for database sake.
Yes. And it's not only that, like the whole, like if we go back to the root, of why NoSQL exists, and why they started to exist. Initially, they tried to offer a different solution that SQL could not fulfill, right? And so basically the main problem of SQL databases in general is that they don't scale well, right? They were designed like in the 70s or 80s now, so like 40 years ago now, And at the time, internet was barely a thing. So they had no idea that, they would serve, those kind of massive systems that we have today, like Netflix, LinkedIn, Facebook, whatever, right? This was like not even a dream, at the time. So they were not designed, in that perspective in mind. While MongoDB is now like 12 years old, I think, maybe 13 now. So this was created with that in perspective, right? The Web 2.0 or 3.0, whatever you want to call it. But this was designed with this in mind. So, for example, when they created NoSQL, they dropped everything that was preventing SQL databases from scaling, like joins, for example, or ACID transactions. All those things, were dropped in favor of scaling, right? So MongoDB was built first with scaling in mind, with the replica set, the high availability, the sharding, so you can, distribute your workload on multiple shards, and so multiple servers. So that's called horizontal scaling, right? Versus vertical scaling that usually do in the SQL work, right? So, and once the technology was proven to work, and once we had the scaling basically in place and working correctly, after a few years, we started to redevelop actually those features like joins, which in MongoDB is $lookup now, or we started to develop as well like the ACID transactions, but now they exist in a distributed system, which is very different, right? So those features were added again, but later in time, right? They came as a second-hand feature, if you see what I mean. Like, and it was only possible, I think, in this direction. That's why today, like databases like Oracle, MySQL, etc., they have issues to scale because they were not designed that way in the beginning. They still have to develop scaling now, but with those pre-existing problems of, ACID transactions and join and all those pre-existing features that are blocking them from really scaling correctly.
Yeah, that's interesting. I can see, the web scale is definitely a different beast, and I can support in the fact that vertical scaling of massive databases is not easy, and it's really, really difficult to do and support a wide variety of use cases that the web introduced. And that's one of the reasons I switched to doing APIs, is because I got tired of doing that database work, and I enjoy APIs a lot more. So what else? This, you have this progression of capabilities that are designed to support not just web scale, but the needs of web and mobile applications, where you have latency over networks, you have different levels of quality of networks, you have multiple devices. Like what else does MongoDB kind of enable when it comes to that type of world that we operate in now?
Yeah, so basically that also what you get basically for free. Once you enable the scaling and the sharding, you get the possibility to distribute your database across the world and across. So we work with AWS, GCP, and Azure on MongoDB Atlas. So you can create those clusters with a few clicks. You can just select the regions where you want to deploy your database, and so you can distribute freely, your database across the globe to reduce the latency, or solve the problem of data governance, for example, with GDPR and, I don't remember, is it the Patriot Act or something like that in the US?
CCPA is in California, is what driving it. So,
okay, I completely forgot the name, but something like that. So GDPR equivalent things, and so you need to, make sure that the data of some particular countries, stay in certain countries. So you have to deploy, a particular cluster in that place, or a shard at least, and make sure that data stays, in that country, for example. So that's basically what MongoDB offers. Yeah. I forgot the backbone of the question. But you get a lot of features like this from MongoDB, and so that's just for the scaling part, right, and the distribution part. But MongoDB is a fully featured database, right? So basically anything you can do with SQL today, you can do with MongoDB as well. Like we have ACID transactions, like I mentioned. Recently, we added some special time series collection, for example, to to, answer better, like have a better answer for people with time series workloads. We have a lot of features, like I don't know where to start, but we have the aggregation pipeline, for example, that makes easy to transform and reshape the data and serve it correctly to your users, for example. We have, and like that's, well, I'm just talking about MongoDB here, which is right the core database system that we have, right? But MongoDB Atlas is a fully fledged data platform, which enhances the whole experience for the user, right? So in MongoDB Atlas, you have like the monitoring, you have all the automation to upgrade or update or create new MongoDB clusters. You have all the monitoring in place, and you have all the automated backup, for example. And you have also some other tools on the side that are actually very practical, that it make your life a lot easier. Like, for example, you have MongoDB charts, which permits you to build those nice dashboard, nice charts. You have also MongoDB Atlas Data Lake, which is a way to retire your data that is, getting old in your main hot MongoDB cluster. That is, of course, more expensive. You can now retire and archive data to AWS S3 buckets, for example. So it's a way to, save money, actually, because if you are working every day with like 3 terabytes of data and one is completely cold data, you can actually, maybe reduce the size of your hot main cluster and put some data in the cold AWS S3 storage, so you can save money, right? Because of course it's a lot cheaper there. And on top of that, we have a feature called federated queries, which is built in MongoDB Atlas Data Lake, which actually allows you to send a query to the 2 data sources that you have now, because you have the hot and the cold data, and you can actually send a federated query that's going to be resolved, on both sides and then merge back, at the end. So it can be completely transparent for you whether or not you are querying cold or hot data, right? And that's super cool. Of course, it's going to be slower if you, hit the cold data, but it's a way to make sure that all the data that you archive, you can actually still query them and use them and find value, in that old data that can still be useful for, reporting, for building, some kind of pages on the side for marketing, maybe purposes or whatever.
Yeah. So on the API front, REST APIs are the most common approach to APIs, but really nowadays on top of databases, we're needing a whole spectrum of, we need GraphQL, you mentioned Kafka, we need streaming. What sort of APIs does Mongo enable these days?
Well, you can build anything, you can really build anything on top of MongoDB, but we built something that's called MongoDB Realm, which was the consequence of the acquisition of the Realm company that we bought like 2, maybe 3 years ago now. And we fully integrated the Realm tech in MongoDB Realm now. So in MongoDB Realm, you can see that it has a serverless backend system that's living on top of MongoDB Atlas, right? MongoDB Atlas is where you deploy your clusters and where you store your data. So that's like kind of the data layer of your application. MongoDB Realm basically sits on top of MongoDB Atlas, and that's where you can build your backend system basically in that serverless environment. So for example, you can host a GraphQL API, which just a few clicks. You basically just enable it and you get an endpoint. You can also enable the authentication system, and basically out of the, in like 5 minutes, you get a GraphQL endpoint that you can use to build and connect your front-end system on top of that. Front-end system that you can also host directly in MongoDB Realm, because there is a hosting part. So you can also host the front-end, for example, built in React or Vue.js or whatever. You can also host it completely in Realm. And so you can really like host the whole thing in MongoDB Realm if you like. And you can build a REST API as well. We have something called HTTPS endpoints. And you can also build like REST APIs in there. That's actually what I used in one of my recent projects, which we call the Open Data COVID-19 project, which we developed about 2 years ago. About 2 years ago into January 2020, really when the COVID outbreak started. So we started to develop this project where we wanted to make the data about COVID available to everybody. And so we are actually serving freely a REST and a GraphQL API that anybody can use, and they're actually using it. It's actually very, very successful at the moment. I don't have the numbers in mind, but I have a few thousand queries per hour running on the REST API, for example, which is hosted by RHEL. And we are just serving this for free for the community, and they build, whatever charts, whatever, data they want to provide. And
Can you share a little bit more about how, because I know there's quite a few data sources available for COVID-19, but there's only a certain amount of good quality data sources. There's a handful of spots. So can you talk to me about how you aggregated that data and made it available via the database?
Yeah, sure. So the only one almost that existed at the time, so in January 2020, was the Johns Hopkins University dataset. Initially, it was provided in a very unpractical Google spreadsheet, which was not really easy to work with, and we could not download it. So initially, I developed like a HTTP parser to just curl the whole page and then extract the data from the HTML page. It was kind of ridiculous. But then soon enough, they developed CSV files, which I put into a GitHub repository, which was way easier to work with. And so what I'm doing actually now, I developed this at least 10 times now, because I changed, the way I interact with the data they provide, etc. So the way I'm working today with it is I work directly with the CSV files they provide in GitHub. I download everything every 4 hours. I have a Python script that runs on that data. They transform all those CSV files into proper MongoDB documents with a proper schema design. Like I said earlier, the schema is very important. So if you want to have efficient queries or, a well-designed and well-crafted REST API or GraphQL API on top of that, you need to work on the schema design first. So that's what I've done here. I transform the CSV files into good MongoDB documents, dates are represented in ISO dates, for example, localization for the latitude and longitude that are represented as a GeoJSON points, for example, etc., etc. And once it is formatted correctly, I just use the MongoDB driver of Python, which is called PyMongo, and I just Mongo import everything. I do an insert many. I just insert the whole thing in MongoDB. Now it represents about 1 gigabyte of data total, because I have measurements, for all the regions in the world for each day. And regions is the vague term, because sometimes it's in the US, for example, it's a county, not the country, the county, right? So it's fairly small. And in other countries, for example, I don't know, Belgium, for example, I just have 1 point for the whole country, right? So it really depends, of which country we are talking about. So the region term is not the same in each country. But that's basically all the data I get, and I get 1 point for every day. And when you multiply this by now more than 2 years, that's what you get, right? So
when you process that new data, is it important, and does it switch it out with what's there already? Is that alive, or is there some sort of switch that has to happen there? How does that work?
Yeah, that's a good question. It's actually a trick that I used. I would say a smart trick. So I actually re-import. Well, the problem first. The problem is that Johns Hopkins University, they are also applying updates sometimes backward in time, right? So it's not a good idea to just take the last day, every day, and just import the last day every day and increment, on that. I could do that, right? But then I would have some mistakes, in the past, because sometimes I apply updates, in the past, because I just, understand after 15 days that actually those 500 people in that hospital, they were actually not, dying from COVID. Maybe they were just sick of something else. And so sometimes I apply those modifications backwards. So just to be safe and just to make sure that the whole data set that I'm importing is actually consistent and correct, I take the whole data set and re-import it entirely every 4 hours. I import that in temp collections. So it's just basically the same name of the collection with underscore temp at the end. And when the whole import is finished, the last line I have in my Python script is actually a rename collection trick. And when you rename a collection in MongoDB, it's actually an atomic operation. So I can basically do like Indiana Jones, in the Lost Temple movie or whatever movie it is. I just, switch the statue, instantly and hope not to trigger the trap. But that's exactly what's happening actually in production. I just replace in one atomic operation the collections that I have. And so from the API user standpoint or the GraphQL API user standpoint, it's completely transparent for them and they just don't see the difference, right? As long as I serve the same data, almost, that's completely the same. What they should notice every day is that there is a new date that's added, every single day overnight for the previous day, of course, but they might also notice some updates, in the past because they applied some differences. And also something we forgot to mention, but I'm just coming back to my mind. You asked about the data source, quality and where it comes from, etc., and why I chose Johns Hopkins University. Basically, if you go to that repository from Johns Hopkins University and check all the data sources that they are aggregated and filtering and cleaning for me before I use the CSV files, the list is actually like super, super long. Like it's basically they use the, healthcare services of all the countries or regions to import all that data daily, and they sort, clean, aggregate, do all the work that's required to provide those CSV files. So there is just no way for me on my own, because there is a whole squad working on this, right? There is no way for me to do better than that. So the data I'm serving is as good as it is, right? I know there are mistakes, in the data set. Like I know it's not 100% accurate. And when you draw the charts, sometimes you can notice some silly numbers here and there, but that's as good as it is, right? I don't want to, I could fix, the data myself and be like, yeah, this point is clearly wrong, right? Like there is like plus 1,000 Ks one day and then it just disappears the next day. There is something wrong, obviously. But I don't want to do that, because if I start doing this, I start altering and starting taking somewhat care, like taking the responsibility of what data I actually serve, while right now it's like as bad as it is. And that's the data that every, journal, every newspaper is actually using today, to follow the COVID numbers, etc. Like, I think like if you check like the real source that they are tracking today, I think it all goes down in some direction. It finishes on the same point, which is, I think, Johns Hopkins University.
Yeah. Well, I really appreciate your time today. It's been fun learning from you about MongoDB and the realm of the database. I appreciate it. Thanks for your time.
Yeah, I was super happy to be here. Thank you very much for listening, and thanks for having me. That's it. I'm super happy to be here.
Yes.
Thanks a lot.
Thanks again to Maxime for stopping by. You can find more about MongoDB at mongodb.com, and Maxime is on LinkedIn. You can subscribe to the Breaking Changes podcast on postman.com/events/breaking-changes. I'm your host, Kin Lane, and until next time, cheers.